Hi, thanks for joining today. This is Jason. This is session 6 of Practical OSPF for Network Engineers with Net.Academy. And a couple housekeeping items. Today we're going to do a demo. Spun it up in Cisco Modeling Labs. If you'd like the YAML for that, please let me know. If you like what we're doing, please go ahead and consider liking the video. If you have comments or questions or requests, please feel free to leave them below. Also, if you'd like to be notified when we have new content, just subscribe to the channel and then click the little bell icon for notifications. Quick reminder. So this demo is going to be all about router LSAs and how the LSAs are used to build the link state database, or the LSDB. So there'll be a lot of show IP route OSPF commands, a lot of show IP OSPF database commands, and so forth. So just a quick reminder on what our LSAs look like. Remember that type 1s and type 2s are inter-area traffic. Type 3s are intra-area traffic. Type 1, 2, and 3 are all your native OSPF internal routes. Type 5, 4, and 7 are all ways to deal with external routes, right? So let's just keep that in mind as we're kind of going through, and we'll see lots of examples of it today. This is just a quick overview of the topology that we're going to be using. And when we talk about intra versus inter-area LSAs, the intra-area LSAs are going to be like the LSAs, type 1s, type 2s that exist within, say, Area 6 as an example, right? Inter-area LSAs are how Area 6 can get to Area 12 via Area 0, right? Not pictured here yet. We will have some external routes coming in off of an EIGRP relationship over on R6. We'll see that in a later slide. With that being said, let's go ahead and hop right into it. All right, we're hopping right into the lab here. Unlike last time, we're not going to do a basic configuration of OSPF. You could watch the previous lab if you wanted to see that. I'm going to assume that OSPF is already set up here. And you can see that we did configure it similar to what we did last time. I have my router ID, my auto cost reference bandwidth set, etc. I've changed all of the networks that were appropriate to point with one exception. The adjacency between R6 and R4. You'll see between R6 and R4, I left it as a broadcast network just so we could look at the different LSAs. So let's go ahead and do that now. If I come over, actually we'll start, we're on R6, let's just stay on R6. If I do a show IP OSPF, show IP route OSPF, I haven't done anything yet. I haven't configured any of the areas to be anything special. All I've done is set up the basic OSPF. And you can see we have a combination of O routes and OIA routes. Those are between intra-area routes, are O's, and OIAs are inter-area routes, right? Intra meaning within the same area, inter meaning between areas, right? Meaning there's an ABR somewhere in the mix. And if we do a show IP OSPF database, you will see that I have my type 1s here, right, for Area 12. I have my type 2s here for Area 12. And I have my type 3s for Area 12, meaning my ABR for Area 12, i.e. router 4, converted from Area 0 into Area 4, these type 3s. If I come to R4, we'll see something pretty different. Same routes. It would be the same routes. Nothing different there. But if we look at the database, it's pretty different. Right? Remember that the shortest path algorithm is running per area. Not between areas, just per area. And so I'll have a database for Area 0 and a database for Area 12, the two areas that my ABR connects, right? So just keep that in mind, right? You're running a database, a shortest path first database, an LSDB construct per area, right? So now let's pretend for a moment that the administrator for area 6 over here, let's say that they said, we're getting all of these routes and we don't really need all the routes that we're getting. I need to know how to get to my native area 6 routes, but really for everything else, I just need to go to my ABR. Can you fix that? Can you do something for me? Well, of course we can, and we know we can, right? We can come in and configure area 6 as a total stub area. So if I come in to the routing process, and I do area 6 stub, and then if I do the no summary command, this is what makes it a total stub. If I just do stub, it's a regular stubby area. When I do no summary, it's a total stubby, right? Why no summary? Because it's telling you no type 3 LSAs, right? What are type 3 LSAs known as? They're known as summary LSAs. They're the ones I don't think are terribly well named, but they're named what they're named, right? So we're just saying no summary LSAs are allowed in. Now, of course, there's one exception, not that it's allowed in, but rather it's generated within the area on the ABR, right? R3 will inject in a default pointing to itself. Okay, we'll see that in a moment. Also, when you make this change, we're going to drop our adjacencies. You can see they just went down, right? And we know that we need to make them consistent. So let's go ahead and do the same over here. Right, and let's do the same over here. Oops. Okay, and now all of area 6 should become a totally stubby area. What does that mean? That means we only take our intra-area routes. If I do a show IP route OSPF now, I should really just get the O's with one IA of a default coming from my ABR. And sure enough, all I have are my O routes and the one OIA, which is a default coming from the ABR. Let's look at that database. Look how simple this is now, right? No type 3 LSAs, no summary LSAs any longer. I have my type 1s. There are no type 2s in area 6. There is one type 2 in area 12. And then I do have one summary, which is coming directly from area 6, and it's pointing to R3, 172.16.3.3 is the router ID for router 3, which is my ABR, right? So that's how we would make something a totally stub area, right? And what it looks like, what it does to the database. Let's next look at, let's say that the administrator for area 12 wants to make just a regular stub area. Okay, so this is again our topology. We're going to make area 12 a stub area, right? And so that's routers 4, 5, and 6. So let's come on over there. Here we're at R6. And we don't need the no summary because we're just making it a normal stub area, right? We'll drop our adjacencies, of course. And lastly, we'll do the ABR. Okay, if I do now, we see that area 12 is set up as a stub. If I take a look at my neighbors, show IP OSPF neighbor, we can see I'm back to everything's in a full state, right? And if I come back here to R6, and I look at my OSPF routes, if anything, my route table grew, right? Why did it grow? It grew because it added in this default, right? But the important thing to know is in a stub, it takes 1, 2, and 3 LSAs, type 1, 2, and 3 LSAs, or basically all my internals, right? Now, it won't take any externals, right? Neither will a totally stub, won't take any externals, right? They're going to follow that default, right? To get to their ABR, to get to the rest of the routes, including externals. So let's come to the redistribution next. Okay, we're on R6. This is where we're going to do our redistribution. Let's just come back. Here's our new, how we're going to introduce our external LSAs, right? We're going to introduce them like this. So you can kind of see that when I look at EIGRP right now, there is no redistribution being done. When I look at OSPF, there is no redistribution being done. You will see that I have some prefix lists and some route maps all pre-configured. That is all done. But what will happen when I redistribute into area 12, however, I'm a stub, right? Because what does redistribution mean? Redistribution means I generate one type 5 per prefix redistributed, and I generate a type 4 for each ASBR that's doing redistribution. However, I've configured this area to be a stub area, which doesn't accept type 4s or 5s, right? No external routes. Well, let's go ahead and do the redistribution first. And you will see we get an area right away, right? ASBR without valid area. Router is currently an ASBR while having only one area, which is a stub area, right? So it's letting us know our redistribution doesn't work. And indeed, if I come over to R5, I still have my neighbors, right, to R4 and R6. I should be learning my externals from R6. But if I come in here and look at my OSPF routes, I'm not learning any of those 192, 168s, right? So what's the solution to that, right? If I'm going to make area 12 a stub, how would I get that to work? Well, I can't make it a stub. I have to make it an NSSA or a not so stubby stub area, right? Recall that what the NSSA tag does is it converts it to a stub or total stub area, either one, with an ASBR. It turns those type 5s into type 7s. When the ABR gets the type 7, it changes it back into a type 5. So we're going to have to convert this to a stub, a NSSA area. Okay, so here we are. This is R4, my ABR. You can see it is currently a stub. It turns out stub and NSSA are going to be mutually exclusive. They don't stack. So I'm actually going to have to back out the stub config and add in the NSSA config. And I'm going to have to do it for the entire area, right? Okay. There's our 4. Our 5. And there's our 6, right? And if we look at our adjacencies, they should all be back up. And sure enough, they are. Now, let's do that redistribution again. If I come over to R5 now, let's take a look at the database. Okay, and you can see we have a change, right? We have a change in that we have some type 7 LSAs, and those type 7 LSAs indeed look like they're representing that 192.168 network. And you'll see that they're showing up in the routing table as an N2. We use our decoder ring and look at N2. We'll see that an N2 is an external type 2, the default when you redistribute. And we're going to have a session, maybe next session or the session after, on redistribution and external routes in general. But this is specific to the not so stubby area, right? N2 is something that will only appear in the NSSA. Meaning, if I come back over here to R3, which isn't an NSSA, you'll see it looks pretty different, right? No type 7s over here. And if I look at the routing table, I just see E2s. E2s are a normal default behavior for redistribution, right? If I come into R4, it's going to have a pretty big database here. Oops. Because this is where I'm converting my 7s to 5s, right? And we should have a 1-to-1 relationship there, right? And we do. Okay. So now we should, in theory, be able to ping all the way from R1 to R7, or my EIGRP router. Let's come over here. And sure enough, I can. Even though R1, if I look at his router table, he doesn't have any external routes, right? Why? Because he's a totally stubby area, right? So he only takes type 1s and type 2s. Then he takes a special default summary LSA type 3, which points to the ABR, right? Likewise, if I look at his database, very clean, no changes whatsoever, right? Makes sense? If you do have questions, please leave them in there, but let's just recap real quick. So our type 5s, they're generated on the ASBR. There's one LSA per prefix that's redistributed. Our type 4s are generated on the ABR, and there is one per ASBR in that local area that's doing the redistribution. Recall that those type 1s and type 2s never leave the area. That's why the type 4 is necessary in the first place. Type 7s, while they're much more rare and they deal with an NSSA area, which is also kind of rare, it's important and useful because it's showing us how a link state protocol with a database similar to OSPF is dealing with these challenges. You might ask, well, why would I do that, right? Why would I even have these weird areas? First of all, you don't need to, right? You don't have to. You could just have everything be in a full area. Back when I first got into networking, which is quite a while ago, they were pretty common to do totally stub areas because back then the routers didn't have much memory. They didn't have much CPU. Running that algorithm's an expensive process, particularly from a CPU perspective, right? And so we would do whatever we could to minimize, right? To minimize the link state database and the processing, because basically you populate the database first and then you generate the IP routing table off of that database, right? So if you have massive tables, it takes a lot more processing power. You could also be in a situation where you inherited a network and it's difficult for you to get the maintenance windows to clean this sort of stuff up. As you can kind of see, if we need to make changes from like Stub to NSSA, it might be easiest just to get rid of the stub altogether and just make it a normal area. But if for whatever reason you couldn't, you couldn't. Or you inherited it and it's already an NSSA, right? But you want to make sure you understand how that's working. Hopefully you got something out of all that. I want to thank everyone for their time. If you have comments, please leave them below. If you have questions, please feel free to email me. And I will see you in the next session.
Need help? Call our cybersecurity team and book a consultation with us today.